All right, our last geometry lesson of chapter 6 is about trapezoids and kites. So we're going to start with trapezoids. So there are isosceles trapezoids and there are regular trapezoids. An isosceles trapezoid is what looks like our first picture. It did not copy very dark. I'm sorry about that. TRAP trapezoid is an isosceles trapezoid with bases RA, so this is a base, and TP. So even though a base sounds like something it sits on, that's a base, and the other one that is parallel to it is also a base. And really, trapezoids, the only specific thing about trapezoids is its bases are parallel. In this particular isosceles trapezoid, the sides that are not bases, which by the way are called legs, these are called the legs, these are congruent, but that doesn't always have to be true with a regular trapezoid. For example, this is also a trapezoid. These are parallel, and that is it. It's just that in this specific trapezoid, where it's called an isosceles trapezoid, these two side lengths are the same, but that doesn't have to be true in a regular trapezoid. Isosceles, though, is special. So if it's an isosceles trapezoid, which means these two side lengths are the same and the bases are parallel, sorry, side lengths, I meant legs, what happens is in an isosceles trapezoid is it makes the base angles congruent to each other and the other base angles congruent to each other. So this is a specifically isosceles trapezoid. So let's look down here at this picture of an isosceles trapezoid. It says measure of angle C is 65 degrees, which is already marked up. What would angle D, E, and F measure? So since it's an isosceles trapezoid, if this is 65, then this base angle down here is also 65. Okay, and then what I would do is, I know it's a parallelogram, which is a four-sided shaped quadrilateral, which has 360 degrees. So I would take my 360 degrees and subtract out 65 and another 65, and I have 230 left. Since these two base angles would also be equal to each other, I can take my 230 and divide by 2, and I know that each of these would be 115 degrees. All right, so here's the deal with the theorem. If a quadrilateral is an isosceles trapezoid, also its diagonals are congruent. So AC would be congruent to BD. All right, so let's look at a practice problem of that. This is an isosceles trapezoid, meaning this is the same length, meaning this and this and this and this are equal. And it says WY is 12. So from here to here, the whole thing that I'm darkening in is 12. If that is 12, then XZ has to also be 12 because they are congruent. So XZ would also be 12. All right. Let's go actually back a page. I think I stapled this in the wrong order, or just find this paper wherever it's at. This gives us some additional vocabulary support that I think we need, because this one tells trapezoid and then later it shows isosceles trapezoid. So let's look at just a plain old trapezoid first. It's a quadrilateral with one pair of opposite sides, and these sides happen to be called the bases. So this is a base, this is also a base. This is a leg, this is also a leg. But the legs have nothing special about them. Oh, sorry, moving on to the next one. The legs of a trapezoid. So the legs would be here. I'll just say that we've already drawn them here. Okay, the bases of the trapezoid are parallel to each other. Bases are parallel. That's the only really cool thing about a trapezoid, besides that it only has four sides. The bases are parallel. Just the bases, not the legs. Okay, and then we drop down here to an isosceles trapezoid, which we've kind of already talked about. It is a trapezoid with legs that are congruent. So here are the bases. Oops, sorry, there's the leg. There's the leg. They're congruent to each other. Now here are the bases, which don't have to be the same length, but do have to be parallel to each other. So the bases are parallel and the legs are the same length. They're congruent. All right, now they're talking about base angles. This has to be in an isosceles trapezoid. Base angles are congruent. So D is congruent to C, A is congruent to B. Okay, and then we're also going to talk today about a kite. A kite is also a quadrilateral, so 4 sides, but the thing that's cool about it is it only has 2 pairs, and they're consecutive, which means right next to each other, of congruent sides. So these 2 are next to each other and are congruent, and then these 2 are next to each other and are congruent to each other. So not all 4 are congruent. That would make it a rhombus. Just 2 that are consecutive, and then the other 2 that are consecutive. No opposite sides are congruent. That would make it a rhombus. Okay, now let's go on to some practice, which is the very last page here, and we will finish up. A theorem about a kite is that its diagonals are perpendicular, meaning its diagonals, which if you're making a real kite would be kind of like the wooden sticks part, those happen to be perpendicular, meaning they form perfectly 90-degree angles up here. So we already knew that the 2 consecutive side lengths are the same and the other 2 consecutive side lengths are the same, and now we know their diagonals are perpendicular. They form 90-degree angles. So here we go with some practice on kites. What is the measure of each numbered angle? All right, well, 1, since this is a kite, has to be 90 degrees. Angle 1, 90 degrees. Okay, angle 2, if this is 52, we can just subtract from 180 because this is a triangle. So 180 minus 90 minus the 52 equals 38. So 2 would measure 38 degrees. Okay, and then angle 3, if this is 52, this is also going to be 52 because these bisect each other, 90-degree angles. So this would also be 52 degrees. Now these bottom ones would not, but these 2 would. These 2 would be equal to each other, but it doesn't necessarily need to be 52 degrees. So angle 3 is 52 degrees. Okay, let's look at this bottom one. So once again, angle 1 is where they bisect in 90-degree angles. So angle 1 is 90 again. If this is 36 degrees, then angle 3 is also 36 degrees. And we can just subtract 90, 36, and question mark in from 180 to get angle 2. So 180 minus our 90-degree angle minus our 36-degree angle leaves 54. So angle 2 would measure 54 degrees.